Hello. In this presentation, we're going to talk about the difference between scientific and everyday thinking. We're going to explore how science requires a set of attitudes and methods to overcome the biases and errors that come with everyday or non-scientific thinking. First, we're going to look at scientific attitudes. Are you curious? Skeptical? Willing to admit that you're wrong in the face of evidence? Then you might have the right set of attitudes to be a scientist. We're then going to explore the necessary steps to be a critical thinker. We're looking at assumptions, values, evidence to come to the right conclusion. Finally, we're going to examine the limits of intuition and common sense. That is, flaws in everyday thinking, systematic biases and errors in thinking that we all share, scientists and non-scientists alike. So first, let's look at scientific attitudes. First of all, a scientist must be curious. When looking at the world, a scientist asks, how can that be, or how does it work? This curiosity inevitably leads to a desire to find out. Have you wondered why someone acts in an irrational or crazy way? Why habits are so hard to break? Or why names are so hard to remember? All of these questions are good ones for a curious psychologist. There are lots of strange claims made in this world, ranging from horoscopes, alien abduction, all the way to perpetual motion machines. While it is fun to entertain such oddities, a scientist should remain skeptical about such claims. This skepticism should be tempered, however, by a willingness to look at the evidence or to look at additional evidence. Finally, a scientist needs to display humility. I'm not talking about the aw shucks kind of humility, but a willingness to admit that you have been wrong in the face of new and compelling evidence. It took a very long time for the world to accept Galileo's view that the Earth goes around the sun and not vice versa. Now let's talk about how we might do good critical thinking. Critical thinking is often cited as a goal of education. What is critical thinking? Well, critical thinking is good, smart thinking that doesn't blindly accept any statement. Think of the famous phrase, "they say." It's used by people who want you to accept a statement uncritically. For example, they say you should drink 8 glasses of water a day. It is often said, but is it true? What are the assumptions behind this? Is it true for a 60-pound child as well as a 250-pound man? Do you get no credit for other beverages like coffee or the water in prepared foods? And by the way, how many ounces are there in a glass? Are there any hidden values in this statement? Is the person who says it a workout fanatic who thinks you should work out vigorously too? Is he trying to make you feel inferior so he can feel superior? Or maybe the person is genuinely worried about your health. What is the evidence that 8 glasses of water is essential? A critical thinker will say, "Show me the study." In 2004, the American Academy of Sciences Institute of Medicine concluded that thirst should be your guideline, not a fixed number of glasses of water. We should conclude, based on the Academy's findings, that we do need water daily, but that food and other beverages can supply the water, in addition to any glass of water we might want to drink. We're now going to turn to how not to think in a way the errors and biases that afflict all of us. We're going to start out by talking about the hindsight bias. The hindsight bias is present in all of us. It's a tendency to see new or confirming information as something that you knew all along. You could have predicted the results beforehand, in other words. Had the results turned out differently, you could have predicted that also. Your book recounts a study by Slovic and Fishoff that presented two groups of participants alleged psychological findings that in fact contradicted each other. One group was told that absence weakens romantic relationships, while the other group was told that research indicates that absence strengthens romantic relationships. Both groups found the results unsurprising and just common sense. It's sometimes called "I knew it all along" phenomenon. Now let's turn to another common error, the false consensus effect. The false consensus effect is the phenomenon that you tend to think that most people share your views and beliefs. We can make the assumption, for example, that everyone in this room is sympathetic to the Democratic Party or the Republican Party. In other words, you overestimate how much people agree with you. Now here's a fellow that assumes that these ladies agree with his assertion. He's about to find out, and he's probably wrong. Now let's turn to the problem of illusory correlation. Illusory correlation is the perception of a relationship between two things, two variables, when only a trivial or absolutely no relationship actually exists. There's an old joke that actually illustrates this. Georgie boy likes hard liquor, and one day he decides to drink bourbon and water. The result? He has a hangover the next day. He tries rye on water on day 2, but still wakes up with a hangover the next morning. Finally, he tries scotch and water, but still gets a hangover. Georgie notes that water is the common element in all 3 days, and vows thereafter to drink his liquor straight without water. A good example of a real illusory correlation is associated with the idea that couples who adopt because they can't conceive later have a natural child the old-fashioned way. And there's a strong belief that this is actually true. And so now we're going to take a look at the idea of illusory correlation over this problem. Let's take the case of illusory correlation where adoption leads to conception for previously infertile couples. The way we would document this, of course, is to find out if couples who adopted later on had children by a natural means. And let's supposing we find that 20% actually had a child by natural means. That also means that people who adopted did not conceive later on at 80%. Now, this still doesn't tell the whole story, because we probably have a sample of people who chose not to adopt, even though they were having difficulty with having natural children. And we want to find out how many of them later on went on to have child by natural means. And let's supposing we find out that it's 20%. And of course, that means that 80% did not conceive. So if we just look at a few cases that we happen to know, the Wilsons adopted, and by golly, they later had a natural child, and so did the Smiths. But you don't know the Joneses, you don't know other families that tried it, and did not actually have a child, nor do you know people who perhaps chose not to adopt, but later on had a natural child. So you need to look at all of this evidence in order to decide whether the correlation is real or not. Now we're going to talk about another kind of bias or error in thinking, and that is called confirmation bias. In psychology and in cognitive science, confirmation bias, also sometimes called confirmatory bias, is a tendency to search for or interpret information in a way that confirms one's own preconceptions, leading to a variety of errors. We all like to have our beliefs confirmed, and confirmation bias is a good way to do it. One way we do it is in an everyday life. We seek out information to confirm our beliefs, and we actively avoid information that challenges our beliefs. We tend to look at news outlets, we tend to look at television, we tend to read things that already confirm what we know. And as a result, we may in fact get a very distorted view of what's actually going on. In science, you have to really work hard to avoid confirmation bias, because when we have a hypothesis, it's very, very clear that we really want it to be true. And as a result, we need to be very, very careful to recognize that we are seeking information, or perhaps in the case of science, interpreting information that confirms what we would like to believe. The next error we're going to talk about is called probabilistic thinking, and we're not very good at it. Let me ask you this question. When you look at these two sets of cards, which one do you think is the more probable? Is it going to be the straight, ace-high straight of hearts, or is it going to be the other combination? We're not really very good at sorting this out, and here's why. People impose meaning on random patterns. If you're playing poker, you're imposing a lot of meaning on a straight. But a 5-card straight is no more or less probable than any other 5-card combination. It's only the fact that we impose meaning on it that makes it seem unlikely. Patterns actually occur very naturally in any random sequence. And in fact, sometimes we're fooled. If we think a whole series of heads show up, then we think the very next one is much more likely to be a tail. And it's not always the case. We also don't look for things that are just as likely as any other. Nobody ever says, look, 1, 4, 3, 6, 5, 2. How about that? But they might say that with 1, 2, 3, 4, 5, 6, which of course is already stuck in our head as a meaningful pattern. The truth is, we're not very good at estimating probabilities. And gambling losses, at least for most people, prove that we're very bad at it. Well, there you have it. Scientific thinking involves the attitudes of curiosity, skepticism, and humility. A good critical thinker examines assumptions, values, and takes a careful look at the evidence, and most of all, draws the right conclusions. Finally, we note, in contrast, that everyday thinking involves a number of errors and biases, namely the hindsight bias, the false consensus effect, illusory correlation, confirmation bias, and poor estimation of probabilities. Thanks for listening.